Hi, everybody. My name is Jeremiah Hansen, and I am a principal architect on our global field CTO team, responsible for our data engineering and data lake workloads in the field CTO office. I'm really excited to be with you today. We're going to be talking about how to operationalize Python pipelines in Snowflake. So we'll go through some content about our features and then actually get into a demo of that capability. So, all right. So, just to set the stage here, what we're talking about is data engineering with Python. There are many ways to do data engineering in Snowflake. This is focusing on Python and the key components for doing data engineering with Python. It starts in the center with Snowpark, and that's Snowflake's ability to run Python natively in our compute clusters and then support the APIs that you're familiar with. It also includes the ability to have notebooks to develop your interactive Python pipelines and then some Snowflake objects as well, where we can capture Python code and execute it in different ways. And we'll go through these different components during this session. So just to briefly touch on our approach, DevOps for databases is a challenge and has unique challenges compared to application DevOps. And this is something that I've been kind of in both spaces in my career and I've seen this firsthand. But the challenges with data involve the state of data, the amount you have to maintain, and you can't, as you're changing the state of the table, you can't lose that data. A lot of times it's the only copy you have of it. So that's a big challenge. We have to deal with that. And then related to that, rolling back, like if you have a failure, being able to recover from that and restore data. In the past, it's a huge challenge with backups and having to do, a restore, which can take days potentially, and then doing that maybe to a different environment just to recover from this. So those are big challenges. Testing is a big challenge when you're trying to automate anything really, but especially data pipelines. So all of these are challenges that are kind of unique to the database DevOps space. But really, the goals with doing this, DevOps has huge advantages to offer, which really come down and can be boiled down to delivering a higher quality product faster. And so you can see kind of some of the benefits. And this really is a crawl, walk, run. So today I want to go through and talk about different techniques and for a lot of folks, really just to get started. And for some of you watching, maybe it's even to take it to the next level and kind of step up the maturity. So Snowflake views this really kind of have three pillars to help support DevOps and operationalizing pipelines. The first is managing your objects declaratively. The second is around CI/CD and enabling tools to help with the deployment process and automation process. And then on the telemetry observability side, being able to monitor what's happening in React. And we'll go through a number of features in these different categories today. So really just going to spend a couple minutes going through features that are particular for DevOps and help with it. And I thought it'd be fun to lay it out this way. You probably have seen this infinity sign before to capture the development lifecycle. But I put on here the different Snowflake features for kind of some of the core phases of this. And we'll go through these. I'll go through kind of each of these features that are in the blue boxes on the subsequent slides. But we have features in the code and build phase of the development, and in the release and deploy phase, and then in the monitoring phase. So I'll run through each of these briefly and help put them in context. The first is Snowflake Notebooks, and this is a really important feature. There's a number of ways within Snowflake to build to package up Python code, whether that's through a snowpark object like a stored procedure or a UDF. But one of the most popular is notebooks. And this allows you to interactively build and debug your notebooks and then schedule them to run in an operational mode for production use cases. And so this is what we'll be focused on today. The demo will actually include how to build pipelines with notebooks and go through that whole process. Then Git integration. This is really an important feature that allows you to connect Snowflake to your Git repository. And one thing that comes up just to clarify, a lot of customers, when they hear Git integration, think this means DevOps. And really, it's an important piece and it helps with the development lifecycle, but it isn't DevOps by itself. There's still other pieces that I'll cover and you'll see in action that you need. But this does allow you to connect, like I said, your Git repository to Snowflake so that you can use that code in the definition of these various objects like Snowpark objects and Streamlit objects. And it also lets you, uh, with notebooks, check code in. from development environments to your Git repo. So it's definitely is a piece, a building block that we're going to use. When it comes to the different Python APIs, we have two sets of them. This is focused on snowpark. So you're probably familiar with the DataFrame API, which is similar to the PySpark API. We've had this in Snowflake for a while now. And we've recently announced pandas as well. And both of these, so whichever API you're familiar with, you can use it in Snowflake and in our notebooks. And this lets you build, take existing code and run it in Snowflake. And customers that have done that migration, I've spoken to many of them, they find that that code runs faster and for less money, more cost effectively in Snowflake than in Spark-based solutions. So you can take that existing code, run it in Snowflake. The Snowflake command line tool, this is really an important component for both. It can be used for the development process. So as you're building out to deploy to dev and all of that, all of those kind of iterative use cases, but also in your CI/CD pipelines, in the automation of the deployment, this becomes a key component. And the Snowflake CLI has support for specific object types, as you can see on the right there. So whether that's Streamlit or container services or Snowpark or native apps, you can use the CLI to help build those quicker and develop and debug faster. So that's really, this is an important tool to be aware of as you're getting into development and operationalizing. Also on the deployment side is this execute immediate command, which I'll show in action, but this lets you take a SQL script that's in a Git repo or a stage and execute it directly inside of Snowflake without needing to have it running in an external compute service. So this is a really powerful feature. A lot of times customers would run a script in some external process like Lambda functions, things like that, in order to execute, or on a VM in EC2, where now you can actually just run them directly. So very powerful. And then on the API side as well, we also have management APIs in Python. So this allows you to actually perform CRUD operations on objects with native Python class structures and semantics. And so whether that's viewing, reviewing what objects are already there, inspecting them, creating new ones, updating them, or deleting them, that can all be done now through this uh, programmatic interface in Python. And this is pretty powerful. This is based off our REST APIs as well, which is a new feature that underpins this. I'll just briefly mention on a database change management side, this is important. This is a feature we're working on and is coming along. We're going to share in another session. We're going to share more details on this. But this is a feature that we support now in preview for a number of objects, but we'll continue to build out over time and we'll eventually provide the ability to potentially replace tools like Flyway and Schema Change and Terraform with native Snowflake capabilities. So stay tuned for that and check out the other session. And then finally, on that observability side, Snowflake Trail is a name for a collection of features in Snowflake that are all about that. So whether it's logs and tracing to actually capture important information about your pipelines, to setting up notifications for certain conditions, and then ultimately alerting and taking action on those, which is, if you remember the infinity sign, this is definitely a key aspect of the overall lifecycle. And so those features are there. So as we put this all together, the idea here, and you'll see this in the demo, is this is a pattern that's common that I've seen with a lot of customers, where you could actually put, so you have in your Git repo, you'd have your various objects, like your notebooks and your different objects. We can have some deployment scripts as well. And we can use the execute immediate command in Snowflake to actually run the contents of those SQL scripts, which can basically deploy or create or alter, create or replace those various objects. And then that whole process can be run manually, but also for production deployments or automated deployments, you can use the Snowflake CLI to help with that. And the demo will show this all working end to end. All right, so probably the part you're most excited about, we're actually going to get in and show the demo, show this how this works. Before I flip over to the demo itself, I wanted to just set the stage on what we're going to cover and what you're going to see. So the idea here is we're going to build two pipelines with notebooks. And so you can see the blue boxes here under with the 5 and the 6 numbers next to them. Those are our pipelines. The first pipeline is going to read files from Excel from a bucket in S3 and load them into corresponding tables. And the second notebook is going to combine those two tables of data with data from the weather source data share and produce this aggregated table, which we call daily city metrics. So those are the two pipelines. You're gonna see Git integration, all of that, and then we're gonna schedule them with tasks. So tasks in Snowflake is our orchestration capability. We're gonna schedule those, and then we're actually gonna deploy the whole thing through an automated pipeline using GitHub Actions. All right, so everything I'm showing you is part of a quick start. And so a quick start, this quickstarts.snowflake.com site is a great one to have bookmarked. This website has a number of really step-by-step guides or hands-on labs on a number of topics. And so in particular, I'll have a link to this at the end with a QR code so you can find this easier. But if you searched in here for notebook, you'll find a notebook called, or a quick start called Getting Started with Data Engineering Using Snowflake Notebooks. And this is what I'll be going through today. But this is all available for you to do as soon as we're done with this session. You can go through and do this yourself. So all the details are here laid out step by step. All right. Next, I've already done a few of the setup steps that you would go through in the quick start. One of those is forking the repository with the code in it that you need. And so I've got that all set up here. And I wanted to just show one thing. Um, when you look at the code, I mentioned we're primarily working with notebooks. If you look carefully here, I just wanted to show what you're seeing. So when you store a Snowflake notebook in a Git repository, it consists of two files, an IPYNB file, which is your notebook file, and then a separate environment YAML file. And this defines which packages are used by the notebook. So those two files together make up a notebook. And you'll see that as we go through here today, but I think that'll help kind of orient you to what we're going to see. So this is a notebook that I've already opened up that is called 00 Start Here. You'll see this as you go through the quick start. And the idea here is this notebook is going to help us do a few things. So I've already run through a few steps. This helps you do the setup. I've done that already. We'll skip past the setup part. And the first step I'm going to actually do together here is we're going to deploy the notebooks into our test environment. So so you can see that there's no funny business, that everything is being done here live in real time. If I refresh a few times here, the demo database has two schemas, the dev schema and the prod schema. And this is where we're going to store our objects. And so for this demo, I'm capturing the idea of pre-production, like a dev environment and a prod environment, using one database with schemas. In the real world, there's actually a lot of different ways to do this, depending on how you've set up Snowflake and how your deployment process is set up. So this is just done to keep it simple, to show you the point, to illustrate the points. You can adapt it, of course, to whatever process you have. So we have nothing in dev and prod. On the integration side, we have set up a bunch of the stages already. We set up the Git repo, and you can see here in Snowsight, we have an integration with Git, and you can see already I can browse that. So just like I did through the GitHub UI, I can actually click in and browse through the repo here as well. So we have some native features with Snowsight. But let's go back over. Let's actually deploy some notebooks. So at this moment, if we're to look at our notebooks, I've got for this role, this demo role, I have no notebooks defined. And I'm going to deploy those actually by running this command, this execute immediate from command. And while this is running, I want to just explain how it works. So the script that I'm running is a SQL script that's actually stored in my Git repository. And I'm passing two parameters to it. I'm passing an environment variable and a branch variable. So you can parameterize these scripts as well. And it's actually finished already, but really quick, I want to show you what this script looks like. This is important for you to see what you can do with this powerful feature. It's a SQL script that uses Jinja. Jinja is a Python templating language that was for website development that has been applied to a lot of things. It gets used in tools like dbt and lots of other places. And here what we're doing is these double curly braces, these specify essentially a placeholder for a variable. And so here I can use the environment and the branch variables to parameterize this script. So basically what I'm doing is deploying two notebooks, running the create notebook command followed by an alter notebook command. Um, and the same script now I can use for development and production or any other environment I have. So it's just, again, gives you some tools and building blocks you can leverage. All right, so with this, this is now finished. And if I refresh my notebooks view over here, you'll see that I've got two notebooks. And also just briefly to point out, what I've done here is prefixed those notebooks with the environment. So we'll have dev, and in a minute, you'll see the prod. Again, this depends on how you set up your Snowflake accounts and your pre-production environments. But this is one way to do it and keeps it simple. All right, so opening the first notebook. And again, if I go back to the diagram, just to refresh, we're looking at this this step 6 load Excel notebooks file. And you can see I'm going to take two Excel files and load them into two target tables. That's what we're going to do with the notebook. So first thing I'm going to do is start the notebook. I won't spend a lot of time explaining the notebook interface. This should be familiar to folks if you've used notebooks in the past. But I did want you to know, I don't know if you noticed while I was talking there, from the time I clicked start to when it said active was maybe 3 or 4 seconds, very quick. And this is a really important point. This is Snowflake. Our compute environment, our virtual warehouses are very mature, very fast. They start up instantly. And actually, the warehouse itself probably started instantly. What takes a few seconds is for a process to start on that warehouse, a notebook process that this notebook connects to. And contrast that if you use notebooks with Spark cluster startup times, which can be 3 to 5 minutes. This is a huge benefit for customers to just the development lifecycle time. So we've got it started. I'm just going to kick off everything in the notebook and I'll talk through briefly the components. So again, a lot of these are standard notebook features. We can name our cells. We can have SQL cells and Python cells. We can pass variables between the cells. So here in this first one, I'm getting some context, a database name and a schema name. And then here in the second Python cell, I'm actually using that data to set some context. And this can go both directions. You can have Python variables that get used in data sets that get used in SQL. So that's just nice little bits. I also got logging here. So I mentioned part of observability and Snowflake Trails being able to log and capture details about the execution of pipelines. So here I'm creating a demo logger, and then I'm actually logging just in this case, some informational messages. But we have logging and tracing as available. And then I defined essentially the two notebooks. This could come, you could throw this in a metadata table if you wanted. I just kind of hard coded it here for this demo. But the key thing here, I've got a function, and this function uses regular Python libraries, in this case, OpenPyXL, to access Python files, and reads the worksheet in, and then writes it out to a table using standard DataFrame API methods. And this does schema detection and all kinds of great things. And the thing to point out here is that this applies to really any data type. So Snowflake supports a wide variety of object types, but there's a bunch that aren't supported, like Excel or custom binary formats or other that with using snowpark, using other Python libraries, you can actually process all of these directly in Snowflake, which I'm showing here. So this gives you an example of how to do it, and you can apply this to other formats as well. And then we have a loop, and we just go through and process each Excel file and write them to tables. And you can see here, I've got two tables, location and order detail. And if I flip over here to the database tab and do a refresh, you'll see that in our dev schema, we now have two tables corresponding to those. So we ran the first notebook. Also point out briefly, we've got integration with Git. So you can see on the left side, this is our Git integration. We can see this notebook is part of the dev branch. And the two files we looked at earlier are part of what make up the notebook. And then up top on the right, we've got options like push to Git and schedule, which I'll cover in just a second. All right, so let's go back. Let's open up the next notebook, notebook 7. Again, I'm going to start this up. We'll kick it off, and I'll do the same thing. I'll just walk through and briefly explain what's happening in this particular notebook. So again, that started very quickly. Run it. The top two cells are the same. They just set the context. The The thing I want to point out here is our Python API. So I mentioned the management API or what we call Python API. This lets you do the basic CRUD operations on objects natively with Python objects. So in this case, I'm checking to see if a table exists, and I'm doing that through native Python objects. You could always do a session.sql and have a SQL query there, but with this management API, you can do it in a Pythonic way. And so this is very simple, showing testing for existence. But like I said, you can also create objects, update objects, delete objects. So we're just testing to see if a table exists. The core code is essentially this data frame expression. So again, you can build notebooks. You could have SQL in the notebooks if you wanted, or in this case, since we're talking about Python data engineering, we can use the DataFrame API to build those queries and those expressions. You can also, like I mentioned earlier, you can use pandas now as well. And all this runs natively in Snowflake and pushes down to the Snowflake compute engine. And I've worked with a lot of customers who have migrated, and the story is always the same. These jobs, the code as they take from Spark and run this in Snowflake, they find that it runs faster, which translates to lower cost and just lower overhead and maintenance. So give it a try. Take some existing code you have, run it in a notebook, and you'll see the benefits. And then we have a pattern here to show how to do incremental processing using the merge command. So it's a fully functional incremental pipeline. And then at the bottom, we print out, we have 2 records in the final table, and that's correct. It's a small data set for the demo. Okay, so that shows you the basics of the 2 notebooks. Now what we're going to do is actually, if we go back here, we're actually going to schedule those 2 notebooks. So the way I'm going to do that is I'm going to create tasks. And this is the Snowflake orchestration capability. But since we're talking about Python here, we want to do this in a Pythonic way. And so I'm going to actually use part of our management API includes advanced features for tasks, and particularly the task DAG API. And DAG stands for Directed Acyclic Graph. And what I'm doing here is just setting up some context. This is the key. So what I'm doing is running, and you can ignore this message for right now. This did create successfully. But I'm creating 2 tasks that each execute one of the notebooks. And then I'm doing a deploy step, defining the dependencies and deploying. This might look familiar to you. This is actually the version 1 API of Airflow. So if you've used Airflow to manage your DAGs before for orchestration, now you can do that same thing, but leverage Snowflake and Snowflake tasks. So very powerful capability. And if I go back now to the database and we just look at this, you'll see that I've got in our dev schema the 2 tasks defined. And I can do a graph and see the different tasks. I'm actually going to just kick this off really quick. So you can see the process, but I'm going to run these. It creates a kind of a root task, which is a dummy task. And then it creates the 2 tasks that I asked it to in the right order. And the API manages all of that. So I've got this created. I can look at the run history. This should all be finished by now. That's finished. And it looks like this one is almost done. So I've got the whole thing executed and run there. You can see that. All right, so that shows essentially how to deploy the tasks. The last thing I want to show is how this all gets operationalized. So let's go back and just make a quick change to one of the notebooks. And we'll just pick something kind of arbitrary here. So let's go into notebook 7. And again, this is connected to the dev branch, both of these notebooks. And let's just change this. We'll do something very trivial, right? But imagine you've made a whole bunch of changes. You can see that it shows up as being modified. And so what I'll do now is push to Git. And this is part of our integration with Git in Snowsight. I'll put my just details in here. And then the access token, let me just copy that. There we go. So I can put it'll save it once you put it in the first time. And this now I'm actually going to push this change to my dev branch. So it's beyond the scope of this quick session to talk about, branching strategies and kind of the overall PR process, but I'm going to show you a very simple method here. So I've got it committed now. I'm just going to come out here to GitHub and just create the PR and do that here. So I'll switch to my dev branch. and then we'll actually open a pull request. I'll do this. I want to do this against my forked repository. And you can see here, there's only one change in the one notebook, and I just changed the limit. But again, imagine this is a number of changes. So I can create the pull request. And then again, you're going to have in the real world have much more mature process with stages and different gates and all of that. For here, for now, I'm just going to merge the changes. So what's going to happen now is this is actually going to kick off a pipeline, a deployment pipeline. And I'm going to show you while it's firing up, I'm going to just show you the definition and this is all in the repository that you have access to. So you have the whole starting point. But essentially on a push to main, what it does is it goes through and it just does some basic setup, like sets up Python, installs some requirements, and then it defines, I have some secrets set, and it defines our connection details. Those are stored in GitHub. And you can see here, I'm calling the SnowSQL command, or the Snowflake CLI command. And this is the new CLI that I mentioned. There's a number of features. There's actually some notebook-specific features that are in here that you can call. For now, I'm just running SQL commands. I can call the alter, which is just refreshes the repository, and then I can run that same execute immediate command. So if you remember in the notebook, when I deployed the dev notebooks, I called this execute immediate and I passed dev variables. So now in here, I'm passing prod variables. And that's really the only difference between these. Is I'm calling that same script. So that's great. The same script I used to build pre-production environments and do development, I can use in production, but just parameterized. All right, so let's check and see. So it looks like it already finished. And we can come in and see the steps it went through, and in the actual deployment step, it updated the Git repo and then published the versions. So with that, we can flip back, and now you'll be able to see if I go into the notebooks and I refresh, you'll see now prod versions of those notebooks. So now we've deployed through an automated process the production notebooks. So pretty cool. I mean, that shows you how this all works together. I can then run I could rerun this code that I had before to create the tasks, and I could do this for, say, our prod schema. And if I do this, this will deploy the same tasks now into the production version of that task DAG. So with that, I've got it created, and I can actually now go back. And if I look at the data again, and I refresh my production schema, you'll see I have some tasks here. They haven't run yet, so that's why I don't have the tables, but I can easily kick those off and run those right now. And so that will then create the final tables in here. So really that kind of gives you the overview end to end of how you could do this. This process of actually deploying the tasks themselves can also be automated. In the Git repo, I also have one other script that you can use as a starting point, which is, if it opens up here, in the scripts folder, there's also a script for deploying the tasks in a Python script, so that can be run as part of a pipeline as well. So you can definitely automate all the components of this. And I can look at the run history, and now I can see all of these have completed successfully. And if I go back now and refresh the table, you'll see I've also got my tables. So there we go. I've got a full production deployment done through an automated fashion. All right, so hopefully that was helpful. As promised, you can scan this QR code. That will take you right to the quick start that I showed you. And this will give you a link to the repository with all the code and step-by-steps so that you can recreate this yourself. And that should give you a lot of material to get started with. Looking forward to seeing how you use this and how it helps you. Thanks a lot.